thanking the organisers for this very kind invitation to give this talk today, which is very close to my heart. And the title, as Ken said, is the role of the freshwater environment on regulating smolt behaviour and survival in the sea. Now, recently, the factors regulating Atlantic salmon populations has focused the minds of both managers and biologists. And there's been a lot of interest on marine mortality in particular. And some of the effects that are occurring in the marine environment have been suggested as some things like changes in oceanic conditions, changes in the food abundance and distribution, and also the bycatch from commercial fishing. But what I want to do today is to argue that the freshwater and the marine environment cannot considered to be in isolation, and that the conditions in one environment will affect the abundance and distribution of Atlantic salmon when they move between the two to feed or to spawn. And this is particularly important within the freshwater environment. And what happens within the freshwater, the conditions that the juvenile salmon experience in the freshwater environment, has a big bearing on their subsequent behaviour and survival when they move into the marine environment. Now, the pressures on the freshwater ecosystems are many and varied. I think climate change is a particular concern for the freshwater environment. As you know, the temperature rise is greater over land than at sea, so the temperature differences are quite extreme in some of our rivers. We have increased climate variability. We are finding that there are more floods and droughts in our rivers and streams recently. And there's also a number of changes in the flow patterns, and in the northern latitudes this is principally due to the early snowmelt. And all of these have an impact on the general water quality that the juvenile salmon have to experience in the freshwater environment. So there's a range of potential impacts for the Atlantic salmon in terms of climate change, including the northward shift in their thermal niche, with lower production and population extinction considered to be a problem in the more southerly areas. Also within the freshwater environment, there are various anthropogenic impacts that impact upon our salmon populations, contaminants, increasing abstraction for a number of reasons, also barriers and obstructions to the migration of particularly the adult spawning salmon, and also the sedimentation of the spawning gravels, which are quite well documented. So what I want to do in this brief talk today is to examine the freshwater influences on the biological characteristics and behaviour of smolts, and to examine the changes that are occurring in freshwater and what the resulting impact could be on the marine survival of the fish once they emigrate out to sea. And the three specific issues I want to touch upon today are the impact on smolt size and age, the impact on smolt run timing, but also on smolt quality. And then finally, I want to end the talk by saying a few words about a quite large telemetry program that we've carried out on the River Tyne, where a lot of the work that I'm going to talk about shows that really the freshwater influence does affect the behaviour and survival of emigrating smolts. So to start with smolt size and age, as we all know, generally there is a critical size needed to initiate spawning, and this varies from river to river. And smolts are typically older and slower growing at the more northerly latitudes. Where it's colder, they tend to grow much more slowly. In a lot of our rivers, the smolt size is variable, although there is a broad geographic range in sizes depending on where you look at them. But there's also differences in smolt size within a single river and even within a single tributary. And also there's differences in year to year in terms of the size of the smolts. Now, within a single population, the smolt size and age will depend on growth rates, and typically the size increases with age. Now, there is evidence that the smolt age is actually changing within a lot of our populations. Since 1989, there's been a decline in the mean age of the smolts, and the evidence for this is derived from a number of wild stocks around the North Atlantic, and the information is derived from looking at scales from the returning adults and looking at the smolt ages over a number of years. And what these studies have shown is there has been a significant decline in the mean smolt age in 17 of the stocks, whereas there's only really been a significant increase in 3 stocks. So in general, the mean age of the smolts is getting a lot younger, although there are very broad regional differences in this throughout the geographic range of the salmon. Now, the causes of the change in the smolt age, the evidence suggests that it's increasing water temperatures. This is the main cause, and the past sizes and freshwater growth and the subsequent decline in smolt age. So what's happening is that the quicker growing fish reach the critical size required for smolting a lot sooner, and therefore they run to sea sooner, and therefore the smolt age is declining. Now, while the temperature may be the main driver of this, there are other environmental variables that may also be important, and these include density-dependent effects within freshwater, the availability of suitable prey during the juvenile phase, increased freshwater production, but also changes in the hydrological regime may all contribute to changing this smolt age. So what are the implications in relation to a reduction in smolt size for salmon in the sea? Well, the faster growth is expected to result in a higher proportion of younger, smaller smolts. And we all know that smaller smolts actually experience higher losses in the marine environment. Whether small size has an effect on marine growth or marine residency, the evidence suggests that it may or it may not. So there's conflicting evidence as to whether smaller fish actually result in better marine growth and better marine residence. But certainly the smaller fish that are migrating out to sea do tend to have much higher mortality than the older fish. Now, in terms of run timing, run timing is very important for smolts, and the factors controlling run timing tend to be day length, which is the ultimate trigger, and the run timing varies with latitude, so that the further north you go, the later the smolt season is, the later that the fish tend to run into the open ocean. And it's also been shown that run timing also occurs later in the northwest Atlantic than in the northeast Atlantic. And again, river conditions such as temperature, discharge turbidity, these act as the triggers for the smolt migration. And then migration timing is also affected by the body size of the fish. Generally, in a lot of populations, the larger and the older smolts tend to migrate a lot earlier. Now, the importance of run timing is that the smolts must enter the marine environment during what is called a short window of opportunity. And this is when the environmental and biological conditions are most suitable for maximizing early survival. And this timing is thought to coincide when suitable prey is available and the distribution is such that the smolts can feed on it. But it's also in relation to optimum water temperatures and sea surface temperatures in the coastal zone. And there is a quite nice correlation between the time of sea entry of populations and the subsequent return of spawning adults. So fish that enter at this optimum window of opportunity tend to return. There tend to be more fish returning as spawning adults. So it is a critical period for the smolts. Now, there is also evidence that this is changing. Run timing tends to be getting earlier in a lot of populations, around about 3 days per decade. And again, this is linked to increasing water temperature. And as a result of this, there could be a potential mismatch in this entry of the fish into the open ocean with the optimum marine conditions, particularly prey distribution and abundance. And this has been shown quite nicely in the River Bush. This is data from Kennedy and Crozier. And here you can see that the smolts are running a lot earlier in the bush with time. And again, there's quite a nice correlation between run timing and marine survival. So the earlier that the fish are entering the open ocean, the poorer the survival. And again, this may be due to the mismatch in terms of prey availability and optimum sea surface temperatures. There are also other implications of changes in the river temperature on smolts, and we're going to be hearing a lot more about this later on in the sessions. There are direct temperature effects on smolts. It can affect the physiological processes and growth. It can reduce survival in seawater challenge tests at certain temperatures. And there is more osmotic stress is more severe at sea surface temperatures less than 6 to 7 degrees. Also, there's a risk of elevated energetic costs in behaviour if the fish are seeking out different optimum sea surface temperatures. There's also indirect effects of temperature, and these are mainly through ecosystem changes, reduced food availability, and the potential for increased vulnerability to predators. So all in all, the freshwater environment and the changes are causing the smolts certain problems, particularly when they enter the marine environment. Now I want to talk a little bit about smolt quality. And in particular, I want to talk about the impacts of freshwater contaminants on smolt quality and exposure to contaminants on the ability of salmon smolts to survive when they move into the marine environment. And we've done a lot of work on impact of pesticides, both agricultural herbicides and agricultural insecticides. And we've dealt, as I've said, mainly with the smolts. And as we know, this is a period where there's significant morphological, behavioural and physiological changes in the fish, and they all go to helping the fish to become a marine animal, adapting to a life in the marine environment. So there are a number of physiological biomarkers associated with the past smolt transformation. During the smolt period, there are increases in gill sodium potassium ATPase activity. There's changes in plasma ions such as sodium, potassium and chloride. There's increases in thyroid hormones, the T3, T4, that allow them to adapt to salt water, but also initiate migration in the smolts. And all of these allow the fish to adapt to saline conditions. And a lot of these processes are actually occurring in the freshwater environment. So smolts tend to be adapted to a marine environment before they leave freshwater, and that seems to be the major impetus in initiating the migration because the fish are adapted to salt water and need to move to a marine environment to survive. Now, what we've been doing is to use these biomarkers to look at the impact of contaminants on smolt physiology and behaviour, and to see how contaminants affect the physiology of the fish and its ability to adapt to salt water. And one of the best examples that we found so far is the herbicide Atrazine. It's a post-emergent herbicide. It was banned in England and Wales in 2006, but still occurs in quite high levels in a lot of our southern rivers. It's still monitored by the EA, but it is widespread in other countries, particularly the USA, for use on particularly sweet corn. Now we've shown that exposure to smolts in the freshwater environment, to environmental levels of atrazine, actually does affect the migratory behaviour of the fish. So increasing concentrations during the smolt stage, you get a general decrease in migratory activity of the downstream moving fish. And again, as I say, this is really at environmental levels. Another impact of atrazine on the smolt is it does affect the sense of smell. And where fish are exposed to, again, very low levels of atrazine, the ability of the smolts to detect specific odorants, such as urine, which we think is used in the imprinting process in the smolts, is significantly reduced. So at 5 micrograms per litre, you can see that the ability to smell particular odorants is significantly reduced. But I think the most thing of concern really is the impact of a lot of contaminants, and this is atrazine, on marine survival. So exposing the smolts in fresh water to low levels of this particular contaminant doesn't actually affect its survival whatsoever. You can catch the fish, they look nice and silvered, but what it does do, it does reduce the physiological ability to adapt to salt water. So if you measure the gill ATPase activity in these fish exposed to atrazine, then it's significantly reduced. And when these fish move across to saline conditions, as you would find in the marine environment, you get very high levels of mortality. So what appears to be happening is that the fish exposed to atrazine, the levels of the physiological development is reduced, and so even though they do migrate to the open ocean, there's a potential of high mortality. So certainly in relation to atrazine, and we've shown this for other compounds as well, exposure of smolts to certain contaminants in fresh water does compromise the ability to adapt to saline conditions and the subsequent impact on their survival in the sea. So marine mortality, although it does occur obviously in the sea, may simply be the result that the sea is just too salty, that when they move over there, the high salt content is just really killing them. This is very difficult to manage. Obviously, you can't do much about the marine environment, but certainly you can do a lot about the freshwater environment in relation to clearing up the many contaminants that are present in our rivers and streams. This is a graph showing the rod catch over a number of years from the River Avon in relation to the mean annual atrazine concentration at the time that the smolts emigrated. So this is the mean catch of grilse 1 year later in relation to the concentration of atrazine the year previous when the smolts were leaving. And as you can see, there's quite a nice correlation between the concentration of atrazine within the river and the subsequent catches of salmon 1 year later. It should be said that obviously atrazine isn't the smoking gun. There are many, many other particular chemicals and other factors that are regulating our populations within the freshwater. But I think this is quite a nice example to show that contaminants may be contributing to that. And again, this is another graph showing the rod catch at the year that the fish are returning. So this is fish coming back and the concentration of atrazine in the river at the time. And this may suggest that, again, if atrazine is affecting the olfactory receptors and sense of smell, these fish may not be returning in the numbers to the rivers to be caught. But as I say, there are many, many other factors affecting salmon in our rivers and streams. Another factor that may be operating within fresh water that may be affecting our salmon populations and their subsequent survival when they move into the open ocean are small renewable energy schemes. These are small in run-of-river hydropower schemes that occur within our rivers and streams, and they tend to be built on existing weirs, and they tend to consist mainly of small Archimedes screws. We've been carrying out a number of studies on the impact of hydropower schemes, and Rasmus is going to talk in more detail about this study later on, but we've been doing a telemetry study looking at the movements and behaviour of smolts around a small hydroelectric scheme at Binder Mill on the River Frome, and really looking to see how this affects the behaviour of the fish and their subsequent migration through Paul Harbour and out into the open sea. And it's really an acoustic telemetry study where we tag the fish quite high up in the system. We tag them with Vemco transmitters, 180 kilohertz ones. We release them and then we let them move down and we monitor the behaviour, the delays around the hydropower scheme, and look to see whether the fish go through the turbines, whether they go over the weir, and their subsequent behaviour downstream of the system through Poole Harbour, and whether these fish are able to go out to sea at all. One particular year we tagged 49 salmon smolts, quite small smolts, that's why we used the 180 system. And they tended to move principally when there was a higher flow rate, which is common in a lot of smolt populations throughout England and Wales. In general, we found that only 4 of our fish moved through the turbine. These were then recorded moving through Poole Harbour and out into coastal waters. And again, movement tended to be mainly nocturnal in the freshwater, but more random as they moved through the saline limit and out to the estuary mouth. But we were concerned about what the effects were of fish going through the turbine. So we carried out a series of studies where we introduced smolts at the top of the hydropower scheme. We assessed their conditions, took photos, looked at the amount of scale loss, and then we caught them immediately downstream as they'd passed through the turbine. And then we assessed them once again for damage, particularly in relation to scale loss. And these are the results of the study, and we were getting between 8% and 18% of our fish damaged as they went through the turbine. And we were finding that basically fish either went through the turbine and came out in a completely pristine condition, or fish came out with a huge amount of scale loss, maybe between 70 and 80%. There was also evidence of strikes from the blades on the fish. Particularly this one here looks like there's been a strike by the edge of the blade. But certainly, you know, there was a huge amount of loss. And I think this is abrasion of the fish as it's scraped down the side as it goes through the turbine. We have looked at what the impact of scale loss is on smolts in the laboratory. We carried out a study where we removed between 1 and 10% of the scales from the fish. And we found under these circumstances, there didn't seem to be any impact on the physiology of the fish or on their saltwater survival. And we certainly know that the scales and the mucus is very important in allowing fish to adapt to saline conditions. But certainly small scale loss doesn't appear to be a problem, but certainly the 70% that we were showing in terms of the fish at the Bindon Mill, that would certainly result in high mortalities once those fish moved into the marine environment. Lastly, I just want to talk a little bit about a study we did over a number of years on the River Tyne. This was quite an extensive salmon and sea trout tracking program. In all, we tagged something like 485 adults and over 500 smolts, and the study was really in relation to looking at the construction of the new Tyne tunnel crossing. So it was before, during and after study. But I think this is probably the largest single data set for a telemetry study on a single river in the UK to date. And a lot of the data showed that the river flow was very, very important in relation to the transit time of the smolts to reach the River Tyne estuary. So fish moved a lot quicker, obviously, down through the river when the rivers were high. So in low flows, there was the potential that the fish may miss this window of opportunity when they got to the coastal zone, particularly during low flows. In terms of the behaviour, it was really typical behaviour. Fish tended to move on an ebbing tide through the estuary. This is obviously the most energetic way of moving through a particular body of water. And migration was again out into coastal waters, appeared to be mainly on an ebbing tide, but throughout the time of day. We can see on the left-hand side that the mean time that fish moved throughout the different years varied quite considerably. Some were moving at night, some were moving at day. But I think the most interesting result to come out of this was looking at the difference in survival in terms of the migration from within the freshwater zone and within the estuary. And clearly in most years, survival within the freshwater environment was a lot lower than survival within the estuary. And what was also interesting was when you plot the mean April river flow for each of the years, you can see that survival within freshwater appears to be a lot lower when you have very low river flows. And this was consistent within 2007 and 2009. And this is a nice thing about doing tracking studies over long periods. You can see these differences between years, particularly when changes in freshwater flow are very evident. Lastly, I just put together this other slide which just shows estuary survival from a number of studies that we've carried out for a number of years in English and Welsh rivers. And in general, detection rates within the estuary appear to be quite high. So in a lot of studies, estuarine migration appears to be better, or survival in estuaries appears to be better than in freshwater. And generally that's because fish migrate very quickly under the cover of darkness and are through the system very, very quickly and out into coastal waters. And as a result, they're not available very much to predation, particularly by visual predators. We did get low results in the River Frome for salmon in 2013, but again, a lot of this is down really just to low detection rate by receivers rather than anything in relation to mortality by the fish. So in conclusion, a few words on implication for management. I think the freshwater environment is critical to performance of salmon at the sea. There is increasing and substantial pressures within freshwater on the fish, which provides challenges for both themselves and for managers. But the freshwater is more amenable to management than the marine environment. You can control abstraction, river regulation, you can introduce riparian shading buffer strips, you can manage the catchment, and if you're lucky, you can remove obstructions to upstream migration. But in all, a good evidence base is vital. And we do have a number of evidence gaps. We need to further explore links between smolt size and adult recruitment. We need to look at the extent and significance of this run timing mismatch and what it means to marine survival. We obviously need to do more work on contaminants, particularly in relation to run timing, but extrapolating to the potential effects on populations. Obviously, monitoring programs do provide essential indicators of change and are required for assessing biological responses to a changing environment. And I think to finish, it's also nice, we want to measure smolt quality as an assessment tool for predicting marine survival and adult recruitment. And this is simply taking samples of fish from different populations during the smolt emigration, looking at the biomarkers in relation to adaptation to the marine environment, and just seeing whether or not certain populations at certain times are going to have a lower chance of survival in the marine environment, and using this to predict returns of adults 1 or 2 or 3 years later. So I think that's the way that we would like to see things go in terms of assessing our smolt populations before they ever run out to sea. So I think time is getting on, so I think I'll leave it there. Thank you for your attention.